My viewers to my YouTube channel today. In today's class, I'm going to be solving the Jamb mock physics question for 2025 and 2026. Now, if you're a student that actually wrote the mock exam, you can see the question here so that you can do necessary correction. Now, let's begin with what we have for today. The first question on the board says that a copper rod has a diameter of 4 centimeters. A copper rod has a diameter of 4 centimeters. That's the diameter of the copper rod. And length 0.8 meter. Okay, the length of the copper rod is 0.8 meter. They now said that one end of the rod is placed in boiling water and the other end is placed in ice bath. So the first end was placed in boiling water, which has a temperature of 100 degrees Celsius, and the other part was placed in what? Ice bath, which has a temperature of 0 degrees Celsius. How much heat is conducted through the bar in 1 minute? In 1 minute, the time taken is 1 minute. How will you solve this question? First of all, let's bring out our parameter. Our parameter says that the copper rod has a diameter. The diameter of the copper rod is what? 4 cm. Don't forget that in more physics calculation, our diameter is supposed to be in meter, not in centimeter. So we convert centimeter to meter by dividing the value with what? 100. So we divide this guy by 100. That will give us 0.04 meter. So that's the diameter. Now we can get the radius of this diameter simply by dividing diameter by 2. So our radius will be equals to diameter over 2 to give us 0.04 over 2, and that will give us what? 0.02 meter. So this is our what? Our radius. Now let's continue. And length 0.8 meter. So the length of the copper rod is 0.8 meter. Please, I want you to note this, that length in physics can also be referred to as thickness. Yes, so I can still tell you that this is the what? The thickness of the what? Of the copper rod. Now let's continue with the question. One end of the rod was placed in boiling water and the other end was placed in an ice bath. So the final temperature, which is the higher one, is the temperature of the boiling water. Don't forget that water boils at 100 degrees Celsius. So it is 100 degrees Celsius, while the other temperature, T1, is 0 degrees Celsius, which is the temperature of the ice. The temperature of ice is 0 degrees Celsius. So that is what we have. Okay, then how much heat is conducted through the bar? We are looking for the quantity of heat, H, unknown. Okay, given it through the bar in 1 minute. So our time is 1 minute. Don't forget that we'll solve in seconds and not in minutes. So we multiply our 1 minute by 60 to give us 60 waiting seconds. Are we together? Good. So what do we have to do next? The thermal conductivity, K, is equals to 380 watts per meter per word per Kelvin. This is the thermal conductivity. Now, if these parameters are given to you, how will you solve this question? First of all, you must understand that this is the conduction or transfer of heat through conduction. Heat can be transferred through 3 means. 1, conduction. 2, convection. 3, radiation. So in conduction, we have these parameters given to us. Yes. Now, before you can solve this question, you must understand what we call the law of what? Heat transfer. Heat transfer by conduction. By conduction. The law of heat transfer by conduction is called Fourier law. Take note of that. It's called Fourier law. So according to this law, please take note of this. According to this law, it states that the rate of heat transfer through a material is directly proportional to the cross-sectional area of the material and the difference in the temperature, and inversely proportional to the word thickness or the length. Now, by the law, you have rate of heat transfer is directly proportional to the cross-sectional area. That's number one. Difference in the temperature, which is theta 2 minus theta 1, and inversely proportional to the what? To the thickness, which is also known as the what? The length. Are we together? So please, if I remove my sign of proportionality, I will introduce my word, my constant. So rate of heat transfer will be equals to Ka bracket theta 2 minus theta 1 all over what? The length. Yes, so this is the formula. But don't forget that this is called rate of heat transfer. Rate of heat transfer. Rate of heat transfer. And your rate of heat transfer means the amount of heat transferred per time. So this rate of heat transfer will give us heat over the time taken equals to Ka open bracket theta 2 minus theta 1 all over length. The length is also called thickness. I repeat again. So please master this formula as the formula involving the transfer of heat by what? Conduction. Heat waiting transfer by conduction. Make sure you cram this formula. It is very important. I repeat again. Amount of heat transfer, time taken, thermal conductivity, cross-sectional area, final temperature, initial temperature, thickness. Oh yeah, may we solve the question. Let's solve the question together. Let's solve it together. We are looking for this. So we have H all over time. Our time is 60 seconds. So we have 60 equals to what? K, your thermal conductivity. What's your thermal conductivity? 380 times our area. What is our area? Please take note. Your area, the cross-sectional area of a conductor is pi r square. So that's what we have. And that's why you were given the radius. You were given the radius. What's the radius? The radius is 0.02 what? Meter. So we can simply say what you. If our area is pi r square, it means that we have 3.142, which is our pi. Then r square 0.02 all square. Are we together? Yes. So this is pi r square for the area. Pi r square. Then times change in temperature. The final temperature is 100, which is the temperature of boiling water. And the temperature of the iceberg is 0. So you have 100 minus 0 all over thickness. What's the thickness? The thickness is called the length, and the length is 0.8. So you have 0.8. So what do we simply do? Very easy. Let's multiply all these values together. You have, first of all, you have H over 60 equals to 380 times 3.142 times 0.02 square times, I hope you know that if you minus 0 from 100, you have 100. So times 100. Wow. So that will give us 47.76 over what? 0.8. So what do we do? Simply cross multiply. If I cross multiply, I will have 0.8H equals to 60 times 47.76. Yes. So we divide both sides by 0.8 to calculate to get the amount of heat transfer. H will give us times 60. That's 47.76 times 60 divided by 0.8. That will give us 358.88. Approximately 358.9 joules. This is the amount of heat transfer. So what you have to do is to learn this formula. Your K is called thermal conductivity. Your A is your cross-sectional area, which is pi r squared. Theta 2 is the final temperature or the bigger temperature. Theta 1 is the initial temperature or the smaller temperature. While L is referred to as the weighting, the thickness. Now let's take the next question. The next question says the unit of inductance is what? What is the unit of inductance? Maybe you came across this question in your Jamb or exam and you're unable to answer it. Here's the answer. Your inductance is measured in Henry. Please take note. The unit of inductance is Henry. And the unit for capacitance, though they didn't ask for capacitance, is what? Farad. Please take note of that. It must be what? It must be noted. So please hold on for more questions. Let's take more questions from the Jamb mock exam. Question number 3. According to this diagram, it says the power through the 4 ohm resistor is 5 watts. What is the power through the 2 ohm resistor? Now this is a circuit diagram containing 2 resistors arranged in parallel because they are connected side by side. Do you understand? Now you must understand something here, that whenever a resistor is connected side by side, whenever a resistor is connected side by side in such a way that they are parallel to each other, the voltage through 2 of them will be the same. Yes, the voltage here and the voltage here will be the same. Do you understand? So take note, for parallel connection, take note of that. The voltage remains the same. Voltage is constant. Yes. So if I know the voltage through the 4 ohm resistor, I can use the same voltage here to get my word, my power. Now, they said if the power through 4 ohm, the power that is here is 5 watts. 5 watts. So if I have resistor of 4 ohm, the power is 5 watts. What is the power through this 2 ohm resistor? First of all, I'm going to find their common what? Voltage. Yes, let's find their common voltage. But before we do that, it will be important for us to look at the formula for electric power. What's the formula for electric power, class? There are 4 basic formula for electrical power. The first one is equals to IV. The second one is I square R. The third one is V square over R. The fourth one, power, is equals to the energy transferred over what? Over time. So this is your formula for electrical power. Your I is current. V is voltage. Take note of that. R is what? Resistance. Do you understand? Then time is your what? T is your time taking. So take note of that. So while I is current, V is voltage or potential difference, R is resistance, your current is in ampere, your voltage is in volts, resistance is in what? Is in ohms. Your current is in what? Is what? In second. Now let us take this question. Let's get the common voltage. Now if they gave us the resistance here, R is equals to 4 ohms. This is the resistance of this. And then they gave us that the power, what's the power through 4 ohm? They say it's 5 watts. So power is equals to what? 5 watts. Let's get the common what? Voltage first. Don't forget that power is equals to V square over weighting R. Do you understand? So we can get the voltage. So what do we simply do? Power is 5 equals to V square, which is what we are looking for, over the resistance. What's the resistance? 4. So we cross multiply this way so that V square will be equals to what? 20. Do you understand? 5 times 4 is 20. So from there, our V will give us the square root of 20 weighting, 20 volts. So I've gotten the voltage here to be what? 20 V. The voltage here and the voltage here is the same. So we can now use that same voltage to get the power through the what? 2 ohm resistor. So let's do that quickly. Power through 2 ohm resistor. Power is V square over what? Over R. Don't forget that R this time is 2 ohms. We're looking for the power through this place. So our power, watch carefully, will be V. What's the voltage? 20. So you have square root of 20 squared over what? R, which is what? 2. So power will give us, square cancel the square root. You have 20 over 2, and that will give us what? 10 watts. So the power through your 2 ohm resistor is 10 watts. Take note of that. Get the common voltage by using the formula for power, then substitute into the order to get your answer. Is that clear? Now let's take the next question. An object is projected at an angle of 15 degrees to the horizontal with a velocity of 20 meters per second. Calculate the horizontal distance. Don't forget that in projectile, horizontal distance is also called range. Yes, range. If in projectile motion, your time taken to reach the maximum height If you are looking for time taken to reach the maximum height, time taken to reach the maximum height, if it's this you are calculating for, your formula will be u sine theta over g. Take note of that. Then if you are looking for the time of flight, if you're looking for the time of flight, capital letter T, you have 2u sine theta over g. That means you multiply your time taken to reach the maximum height by 2 to get the time of flight. If you are looking for the maximum height, that's number 3. Maximum height, please write this formula down. In case in your Jamb exam, you are told to calculate for time taken to reach the maximum height, or time of flight, or even the maximum height itself. If you are looking for maximum height, what is the formula? Your maximum height formula is equals to u square sine square theta over 2g. This is your maximum height. Now, if you are looking for range, your range is also referred to as the horizontal distance. Don't forget that. Horizontal distance. So if you are looking for range is equals to u square sine 2 theta, not square. This one you have square, but here is 2 theta over g. Yes. Finally, the fifth formula for projectile is called the maximum range. Your maximum range, arrow, your maximum range. A projectile is set to attain a maximum range when theta is equals to 45 degrees. So if you are looking for maximum range, you must first know that theta is 45 degrees. Then the arrow maximum expression, which is the formula for maximum range, is equals to u square over g. So take note of this formula. Time taken to reach the maximum height, time of flight, write it down, maximum height, because there's no way you do Jamb that will not give you question in projectile. So you must certainly see it. Then this is your horizontal range. Then this is your maximum horizontal range. Okay, and it occurs when theta is equals to what? 45 degrees. But according to this question, we were told to calculate for the horizontal what? Range. So let's calculate for the horizontal range, class. Your horizontal range, don't forget the formula. Your formula says what? U square sine square what? So sine 2 theta over g. Let's get our what? Our horizontal range. Arrow is equals to what? U square sine 2 theta over g. This is your formula for range. So don't forget that your velocity is 20 meter per second. Your angle is 15 degrees. G is 10 meter per second. So let's do direct substitution. So R is equals to 20 square times sine 2 bracket 15 all over what? 10. 20 square will give us 400 times sine what? 2 times 15, 30 degrees over what? 10. So what would that give us? 400 times sine 30 is what? 0.5 over 10. 400 times 0.5 will give us 200 over 10. This cancel this. Your horizontal range is equals to what? 20 meter. Now let's take the next question. Question number 5. He said calculate the relative velocity of two objects having velocities of 80 km per hour and 100 km per hour moving in the same direction. Now, there's what we call relative motion. The principles of combining relative motion is the direct opposite of resultant vector. Yes, in vector, if they move in the same direction, you will add it. If they move in opposite direction, you will subtract it. But in relative velocity, if they move in opposite direction, the same direction, you subtract it. In opposite, you now add. So understand that in this case, they are moving in the same direction. If it were resultant velocity, you would have added them together if they move in the same direction. But here, they are moving in the same direction and they are referring to relative velocity. Relative velocity is equals to 100 minus 80. That will give us 20 km per hour. Why did I subtract it? Because they move in the same direction. If they move in opposite direction, I will do what? I will add it together. It is just the direct opposite of combining two or more vectors. Take note of that. So the answer to this question is what? B. 20 km per hour. Let's take more questions for today class. Question 6 says that the slacking of the ciliary muscle will cause which eye defect? The slacking of the ciliary muscle which cause which eye defect? Now, let's analyze this carefully. You must understand that we are talking about eye defects. For eye defects, there are relatively 4 eye defects. And these 4 eye defects include number 1, short-sightedness. Short-sightedness. Now, it includes short-sightedness, which is also called Wheatstone, myopia. Yes, myopia. What is the cause of short-sightedness? Because now, if this one comes out in mock exam, there is great probability, there's every tendency that you might come across short-sightedness problem in your exam. Do you understand? Yes. They might say, which of this is the cause of short-sightedness? Now, what does short-sightedness mean? It means that the person can only see near object but cannot see far object. So we say that the person is short-sighted or myopic. Do you understand? Good. So it means that can see waiting only close objects. Yes, he can only see objects that are what? Close. What is the cause? The reason is because he cannot see far. The reason is because what is the causes? The causes is simple. Please watch carefully. What are the causes of short-sightedness? Because if you take a look at the diagram for short-sightedness, you have it this way. Now let's assume this is the lens, okay? For short-sightedness, you cannot see far objects, and far objects produce parallel rays of light. Look at it. This is the rays from the object, and then the image, the rays that convert, so that here becomes where the image is. This is the image. Do you understand? Yes. This is the object, while here is the word image. So to be short-sighted means that the eyeball is too long. This place now, which is known as the retina, is where the image was supposed to appear. The image was supposed to appear at this place called the retina, but now it is at the front of the retina. Do you understand? So because the eyeball is too long. So the causes is what? Number 1, eyeball too long. Yes, eyeball too long. That's number 1 cause of shortness. Now number 2, we can say that lens too converging. Too converging, or the lens is too powerful in such a way that it now become converge at this place. Then what is the correction for this short-sightedness? Very easy. The correction here, the correction is use of what? Concave, please take note, or diverging lens. Diverging lens. We use a concave or a diverging lens to correct a short-sighted eye defect. Now, the next one is called the long-sightedness. Sightedness, which is called hypermetropia. Hypermetropia means that the person can only see far but cannot see near objects. Don't forget that short-sightedness means that can see only close objects. It can't see far objects clearly. So it cannot see far objects clearly. But for long-sightedness, it can what? Can only see far objects. Yes, it can only see far objects. Are we together? Yes, it can only see far objects. Can't see near objects clearly. Yes, so it can only see far objects. That's fast long-sightedness, but cannot see objects that are close. Why? It is just the direct opposite of this. Do you understand? So if you look at it very well, the causes here is that eyeball too long. The eyeball is too long, but yet the causes is that number 1, eyeball too short. Too short. That's number 1. Number 2, lens too converging. This one, lens is too weak. Yes, take note of that. The lens is too weak. What is the correction? Finally, the correction is the use of convex or converging lens. Yes, convex or converging lens. You use convex or converging lens for long-sightedness. You use convex or converging lens for long-sightedness. Long-sightedness. Please take note of that. Now, number 3 eye defect that we have is called presbyopia. Presbyopia. Presbyopia is an eye defect that is caused by the slacking of the ciliary muscle or the weakness of the ciliary muscle in such a way that the eye will lose what? Will lose its power of accommodation. What does the word accommodation mean? It is the ability for the eye to adjust the focal length of the lens so that it can focus both far and near objects clearly. Do you understand? So if the muscle is so weak, yes, if the muscle is weak ciliary muscle. If the muscle is weak, the muscle in the eye is called the ciliary muscle. If it is weak, it means that the eye defect that is present is called presbyopia. Do you understand? And when that happens, the eye will lose its power of what? Accommodation. It can no longer focus both near objects. It cannot focus far objects clearly. Do you understand? So what's the causes? I've told you the causes here is slacking or weakness of the ciliary muscle. Yes. What's the correction? How do you correct presbyopia? The correction is by the use of a bifocal lens. Yes, a bifocal lens. Take note of that. Finally, we have what we call the final eye defect, which is called the long-sightedness. Which is called astigmatism. Number 4, astigmatism. Number 4 is astigmatism. The astigmatism is due to the uneven curvature of the cornea. This white part of the eye, this white part is called the cornea. Do you understand? So the cause is that the cause is due to the uneven curvature of the cornea. Yes, the uneven curvature of the cornea, this white part of the eye. Now, if the white part of the eye loses its shape, it causes what we call astigmatism. What is the correction of astigmatism? Astigmatism is corrected by the use of a cylindrical lens. Yes, it is corrected by the use of a what? A cylindrical lens. Now let's take the other question. The instrument which is based on Archimedes principle. So to this question, the slacking of the ciliary muscle will cause which eye defect? The answer is presbyopia. Take note of that. When the eye loses its power of accommodation. Do you understand? Due to the weakness or slacking of the ciliary muscle. Ciliary muscle is a muscle present in the human eye. Now, the instrument which is based on Archimedes principle is what? The answer to this question is a word, hydrometer. Don't forget, I didn't say hygrometer, hydrometer. Hydrometer is a device that is based on what? That is used to measure the what? Relative density of a what? Of a liquid. It usually floats on a liquid. And don't forget that Archimedes principle says that when an object is totally or partially immersed in a liquid, it experiences an upthrust which is equal to the weight of a liquid displaced. So take note, the hydrometer is based on Archimedes' word principle. Do you understand? Number 8, the temperature at which the water vapor present in the air is just sufficient to what? To saturate it. The answer to this question is called dew point. That's the answer. Question number 9. This question is based on Wheatstone bridge. Wheatstone bridge. How is it calculated? Very easy. We'll calculate it this way. Let's create a space to solve the question. We'll calculate it this way. Now, this is a Wheatstone bridge. The formula for calculating the unknown resistance, R1 over R2, is R3 over R4. This is your R1, this number 2, number 3, and number 4. So you have 2 over what? 3 equals to 4 over x. So we'll simply cross multiply. So that 2x will be equals to what? 3 times 4 is what? 12. We divide both side by 2. This cancel this. S is equals to what? 6 ohms. Are we together? Now let's take one more question before we call it a day. Take a look at this Jamb mock question. Okay, this is a diagram for a uniform bar, a uniform metal bar. They say in the diagram above, uniform metal bar of weight 9.1 Newton. This is the weight of the bar. Don't forget that the weight of the bar will be at the center of the bar. The bar is 100 cm long. Here is 0 cm and here is what? 100 cm. So the weight will be at the middle, which is the center of gravity. Okay, let's continue. It's held in a position on the fulcrum at 40 centimeter. This is the fulcrum. Okay, if a weight of 3 is suspended from the 10 centimeter mark, as you can see on the board, and the system is released, the bar will what? What will happen to the bar? Is it going to remain in equilibrium? Is it going to move towards the clockwise, or is it going to move towards the anti-clockwise? It is very easy. First of all, let's draw the diagram again. We have a weight here, which is what? 3 Newton. Hold on, this 3 Newton, and we have our pivot, which is the fulcrum. Here is 10, here is 40. So the distance from here to here, 10 to 40 will give us 30 cm. And then you have 50 centimeter here, and then you have 100. This is the weight of the meter rule or the metal bar. The metal bar weighs 9.1 Newton. So we can put it there, 9.1 Newton. What's the distance from 40 to 50? From here to here will be 10 cm, 10 centimeter. So this is how we can determine if the system will remain in equilibrium or not. If a body is in equilibrium, it means that the clockwise moment will be equal to the anti-clockwise moment. Otherwise, it is not in equilibrium. So let's get the what? The moment of this place, which is called anti-clockwise. Let's get the moment here, which is what? Clockwise. Are we together? So let's get the anti-clockwise here. Then the clockwise is the force times the distance. So you have 3 times 30 here, and that will give us 90 Newton centimeter. We just multiply the force by the distance. Here we have 9.1 times what? 10. So 9.1 times 10 will give us 91 Newton centimeter. So if you look very well, you discover that the clockwise is 91, but the anti-clockwise is 90. So that means it will rotate in the clockwise direction. Rotate to the what? Clockwise direction. Why? Why is it rotating to the clockwise direction? Because the clockwise moment is greater than the anti-clockwise moment. The clockwise moment is 91. The anti-clockwise is what? 10. So the option say rotate in the clockwise direction. That's the answer. It will remain in equilibrium if both of them is the same. So B is not the answer. It will rotate towards the anti-clockwise if the anti-clockwise is greater than the clockwise. So C is not the answer. Neither is word D the answer. We have come to the end of today's video lesson. If today is your first time coming across my YouTube channel, please don't forget to subscribe, to like, and to on your notification bell. In our next video, we are going to be looking at the other questions for the Jamb exam 2025-2026. Thank you very much. I'll see you in my next video.